Welcome back again to engineering mechanics, solving numerical problems from the famous book Engineering Mechanics by Timoshenko. The problem set 2.4, solution to 2.63. Let me read out first the statement. We will find it challenging while applying equilibrium of concurrent forces at the center of this sphere. Now there are three smooth spheres, means there is no force of friction at the points of contact, either here or here or here or here or here or here. Three smooth spheres of weight P, P and Q. The weight of this one is P, the weight of this one is P. It is named as R, and the weight of this one is Q. The value of P, the weight of this one, and the weight of this one are known. Are placed in a smooth trench. This is a smooth trench. No force of friction here, 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 here. Shown in the figure, find the pressure exerted on the walls and at floor at the points of contact A, B, C, D. Look, here is a point of contact, 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 point of contact. So we have to find the pressure exerted here, here, here and here. That is the normal reaction force. And the pressure here and here. The following numerical data are given. P is 0.3 kilonewton. I will convert that to Newton by multiplying it with 1000, so that will be 300 Newton. While solving, Q is 0.6 kilonewton, R is equal to 0.3 kilonewton. Radius of the first sphere, that is this one, is 0.4 meter. Radius of the second sphere, second sphere is 0.6 meter. And the radius of the third one, this one, is 0.4 meter, and this angle of inclination of this inclined plane is given as 30 degree. Very tricky one, but still I'll make it as simple as possible. So main thing is I have redrawn the diagram very nicely with help of these things. I have redrawn the diagram with the help of these things. This one with this one, and these two with two curves. So let me now explain three smooth spheres with center O1, O2 and O3. Let us name their centers. This as O1, this as O2, this as O3. So what you have to find, the reaction force here, here, here and here. Now if you look at, this is circular. So here, this wall is a tangent, therefore this is normal along the radius. Let the reaction force is Ra at the point of A, and it will pass through O1, the center of this sphere having radius 0.4 meter. Similarly, let us come back, let us finish this, then come back here and here. Now here at the point of contact E between this sphere and this sphere, there will be action reaction forces. Let it be Re. So Re for this sphere is towards this side, passing through O1, and for this sphere the same Re is also passing through the point E, because here if you draw a tangent, and this will be normal. It will be passing to O2 and is pointing towards this side, Re, for this one, for this sphere. Now let us come back to this bigger one, whose center is O2. It is in contact at this point and at this point. Here, since this is spherical in nature, circular in nature, here, therefore this is the tangent, therefore this is the normal. So let the normal reaction be RB at the point B, and it will pass obviously through O2. And similarly here to this surface, this red line is the normal, therefore, this red line is the tangent, therefore RC is normal. It will pass through the point C. RC is normal to this curved surface at point C, and this will also pass through the center of this sphere. Now, the weight of this one is vertically downward, is given as Q, that is 0.6 kilonewton. The weight of the first one from the center of mass is vertically downward, and is given as 0.3 kilonewton. So for this sphere we have three forces. One, its weight vertically downward, and the reaction force RE. And for this sphere, there is one reaction force here, RB, one reaction force here at RC, its weight vertically downward, that is Q, and what else? And this point of contact, which is common between this sphere and this sphere, let that point be F. So the action-reaction force RF for this sphere will be to this side, passing through the point O3, the center of it, and pointing to this side, RF. And the same RF for this sphere at the point of contact F is passing through the point F and passing through the point O2, the center of it, and is pointing to this side. So now let us then come back to the third one, this one. This has the same radius as the first one, 0.4. The radius of this one is equal to 0.6 meter. Now here, the weight of this one, the third one, from this point center, is passing vertically downward due to Earth's gravity, that is given as R is equal to 0.3 kilonewton. That is same thing as the first one, the weight of the first one. And here at the point of contact with the surface, to this curved surface, this red line is the tangent. Therefore, this RD, which passes through the radius, is the normal. So RD is the normal reaction at point D for this sphere. Now, fine. Then and what else is given is this angle is given alpha as 30 degree. Now let us explain the different angles. Now look at. So let us begin with, let this angle is equal to beta. This angle is equal to beta. Now from O1 to O2 will be radius of this one, that is R1, and from here to here is R2. So from O1 to O2 is equal to R1 plus R2. And this line is vertically downward. So this angle is 90. And let this angle is beta. Right. Now we'll find out beta by applying cos beta. Cos beta will be base over hypotenuse, that I will explain. The base from here to here will be equal to R2, that is from here to here, R2 minus from here to here, that is same thing as your R1. So this base will be R2 minus R1, and the hypotenuse from O1 to O2 will be R1 plus R2, that is O1E plus EO2. So we'll find out beta. Now then come back here. This is interesting. Now look, this line is vertically downward, this line is vertically downward, this line is horizontal, therefore this angle is 90, this angle is alpha. So in this triangle, I am moving my pen, tip of the pen all along the triangle. So in this triangle, this remaining angle will be 90 minus alpha, because sum of the three angles, this plus this has to be 180 degree. Now, therefore, the vertically opposite angle, this angle will also be 90 minus alpha. Now, if you again look at the triangle, I am moving my pen all along the triangle, that is this triangle, this triangle, this triangle, this triangle. This is 90 here, this I just explained, this is 90 minus alpha, being vertically opposite to this. So the remaining angle, this one, will be alpha, because alpha plus 90 minus alpha plus 90 will be 180 degree. Then how this angle is alpha? Let me explain. This line, the weight of this sphere is vertically downward. So here this makes angle 90 degree. So now in this triangle, I am moving my pen in this triangle, moving slowly so that you can observe. In this triangle, this is 90, this is alpha. So this remaining angle will be 90 minus alpha. So if this is 90 minus alpha, this angle will be 90 minus alpha, being vertically opposite. Now look at this triangle. Now look at this triangle. This is 90 minus alpha, this is 90, so this will be alpha. Clear? Now, now I have drawn a dotted line like this, parallel to this red line. So the distance from O3 to D, that is equal to the radius of this sphere, that is equal to 0.4 meter, will be same thing as the distance from G to C. From G to C will be also 0.4 meter. But from O2 to this point is the radius of this sphere, that is 0.6. Therefore, this remaining distance from O2, from this point to this point, will be this radius minus this radius, that is 0.6 minus 0.4. So this distance from O to G will be 0.6 minus 0.4, that will be 0.2. So let this angle is equal to gamma, and this is the perpendicular drawn to this dotted line. So in this triangle, this angle is gamma, this is 90. So if I apply sine gamma will be perpendicular O to G over hypotenuse O to O3. And how much will be from O to O2, from this point to this point, will be R2 minus R1, R2 minus R3, that is 0.6 minus 0.4, that will be 0.2. And what will be the length of this hypotenuse? That is the radius of this sphere plus radius of this sphere, that is R2 plus R3. So gamma can be found out. So now once that is clear, then we have to find this angle, which I will explain in the last page. Let it be a question mark. We will find it out while discussing. So now let us discuss three smooth spheres with centers O1, O2, O3 to find RA, RB, RC and RD. Now the forces acting on the sphere with center O1, there are three forces, RA, its weight, and RE. Forces acting on the sphere with center O2, this one, this is acted upon by 5 different forces. 1, 2, its weight 3, then this is RE 4, then this is RF. There are 5 different forces. Similarly, the forces acting on the sphere with center O3 is also, there are 3 forces. Its weight, now here the reaction force RF and the reaction force RD at this point. So let us find out first in the triangle, in this triangle, what is the value of beta? O1, this triangle. Now taking cos beta will be base over hypotenuse, that is this distance over O1, O2. this distance is same thing as R2 minus this much, that is R1. So cos beta is equal to R2 minus R1 over hypotenuse, that is from O1 to O2, that is equal to R1 plus R2. So beta is equal to cos inverse of, so beta is equal to cos inverse of this. I have put the value of R2, R1, R1, R2. So beta comes out to be 70.463 degree, that is 78 degree 27 minute 46.95 seconds of arc. Now then let us find cos gamma, the value of gamma. In this triangle O2, G, O3, this line is parallel to this red line. Therefore the distance from O3 to this point, which is R3, will be equal to the distance from G to C, that is also equal to R3, that is 0.4. Therefore O2G will be O2C minus GC, and from O2 to C is equal to radius of this sphere, that is 0.6, and from here to here is the radius of this sphere, that is 0.4. That is from therefore from O2 to G will be 0.6 minus 0.4. So sine of this gamma will be perpendicular O2G over hypotenuse from O2 to O3. So sine gamma is equal to O2G over O2 O3, that is R2 minus R3 over R2 plus R3. I have put the values. So gamma is equal to, I have just solve it, sine inverse 0.2 over 1. So gamma comes out to be 11.5369 degrees, that is 11 degree 32 minute 13.05 seconds of arc. Fine. Now once you are clear about this diagram, we'll apply the free body diagram at O1. At O1, right? Now free body diagram at O1. So for that, taking this as the origin, I consider this as x-axis. So RA is along positive x-axis, and this line, if I extend this line, this is your y-axis, which I have shown it here, and this is your RE, that is same thing as this. The question then, how this angle is equal to beta? Now if you look at this line is parallel to this line, and this line, this direction of RE is transversal. So if this angle is beta, then this will also be beta, the corresponding angle. So the free body diagram is drawn at point O. There are three forces, RA, RE and P, downward. RA is horizontal, so it doesn't have a vertical component. P is 0.3 kilonewton is vertical, so it doesn't have a horizontal component. RE, which you don't know, is making angle beta with horizontal. So let us apply first sigma y is equal to 0. Sigma y is equal to 0. The component of RE along positive y-axis will be from this point to this point. And how much will be that? RE sin beta. And that is being opposed by P. So if they are equal, then it will be equilibrium. So RE sin beta is equal to P. So sin beta comes to the right hand side. So RE is P over sin beta. Value of P is put, sin beta value of beta is put. I convert this to Newton by multiplying with 1000 and put it in a scientific calculator. This comes out to be 306.2045 per Newton. Then apply sigma x is equal to 0. Now this RA is along positive x-axis. Now which is the other one that is making this force 0? From here, if you drop a perpendicular, this component will be your RE cos beta, that is opposite to RA. So RE cos beta is equal to RA. Put the value of RE, which we just calculated, multiply with cos 78 degree 27 minute. This comes out to be 61.308 Newton. Fine. Now let us go to the point O3. that is the center of this sphere, and apply sigma x is equal to 0, sigma y is equal to 0. Little tricky here. So the free body diagram I have drawn here, taking little tricky, but still we'll be able to make it out. Now, if you look at the free body diagram and this diagram, the gamma is here, but I have shown gamma here. How is that possible? Means I have extended this dotted line like this. So vertically opposite to this is your gamma, right? And I have taken this and this dotted line as this line as x-axis in the free body diagram, x-axis, and your RF making angle gamma, RF making angle gamma with x-axis, and this one, this direction I have taken it as a y-axis, which I have shown it here. So RD, if you shift this vector to 0.03, it will be pointing to this side. So this is your RD, and from this point, the weight of this sphere is vertically downward. That is what is shown here, and it is making alpha here. So this is alpha here. So once that is done, now it is very simple. Now, so alpha is given 30 degree, gamma is found out. Now there are three forces, R, RF, RD. This is neither vertical nor horizontal. This RD is also neither horizontal or vertical as per the axis I have taken. So let us apply sigma x is equal to 0. So from here, if you drop a perpendicular, this part from here to here will be your RF cos gamma, and if you drop a perpendicular from here, then this length from here to here will be your R times sine 30, that is sine alpha. So your RF cos gamma goes to the other side. Now just put the values in a scientific calculator. The value of R converted to Newton, sine 30, alpha is 30, cos 11 degree 32 minutes, because that was gamma. So RF comes out to be 153.091 Newton. Then apply sigma y is equal to 0. Now sigma y. Now if you drop a perpendicular from here, this part from here to here will be your RF sine gamma, and from here if you drop a perpendicular here, this length from here to here will be your R times cos alpha. So your RF sine alpha is equal to RD. So RF sine gamma, that is this one, will be equal to your RD. Made a mistake probably here. Sigma y on this axis. So, sorry, you have to make changes here. This one is your RF. This one is your RF sine gamma, and if you drop a perpendicular, this one will be your R times cos alpha. Both are in the same direction. That will be equal to your RT. Now use this relation, put the value of RF, put the value of gamma which you have calculated, put the value of R, put the value of theta, then find out RD. It will be slightly different, I think. So let me check and so make these corrections here. I made a mistake here. So apply sigma y is equal to 0. means the component of RF along y-axis, that is this one, will be your RF sine gamma plus the component of this R along y-axis will be R times cos alpha, that will be equal to RD. Put the value, these values, this comes out to be 291 Newton. Don't look at this part. Now we are finally left with the point O2. We have to apply the free body diagram at point O2. So I have to find out this angle. Now look, interesting. At this point, this total angle is 180 degree. This angle we don't know. Let it be theta. So theta plus alpha, theta plus alpha plus this much will be 180 degree. That is theta plus alpha. And how much is this? Is 90 minus gamma. 90 minus gamma is equal to 180 degree. So your theta is equal to 180 minus 90 plus gamma minus alpha. 180 minus 90, that is 90 minus alpha plus gamma. But your alpha is equal to 30 degree. So 90 minus 30 is 60 plus gamma. So this angle is your 60 plus gamma. That is to be kept in mind. So now let us draw the free body diagram at point O2, considering this line as x-axis and this vertical line along which its weight is acting as y-axis. Then it is simple. I have drawn it here. So this is your x-axis, this is your y-axis. RB is to this side. RB is to this side, which I have shown it here. And your RC pointing this way. So if this is angle alpha, so this angle will also be alpha, vertically opposite. So RC I have shown, making angle alpha with the vertical. Now then comes your RE. If you look at this is the direction of RE. This is the direction of RE. So this angle and this angle will be beta. If you extend the direction of RE and this as x-axis, this line is parallel to this line. The direction of RE is the transversal. Therefore, this angle from here to here will be beta, the corresponding angle which I have shown it here. Then I just explained how this angle, this from here to here is 60 plus gamma. That is RF, making angle 60 plus gamma. Then it is easy. Now there are 5 forces for the free body diagram at O2: RB, RC, RF, RE and Q. Take RB along positive x-axis and Q along negative y-axis. So the diagram is drawn. Now it is simple. RF is known, Q is known, RF is found out, Q is known, RE is found out, alpha is known, beta was found out, gamma was also found out. So let us apply sigma y is equal to 0 first. Means if you drop a perpendicular here, from here to here will be your RC cos alpha. Now RC cos alpha, that is being opposed by, if you drop a perpendicular from here, from this point to this point will be your RF cos 60 plus gamma, and Q is also in the same direction, so it is added. And if you drop a perpendicular here, this length from here to here will be your RE sine beta. So your cos alpha goes to the other side, it is divided. Just put the values in a scientific calculator. Don't calculate individually. It comes out to be 1095.223 Newton. Now once RC is found out, then apply sigma x is equal to 0 to find out your RB. Sigma x is equal to 0. The component of RC, if you drop a perpendicular, will be from here to here, will be RC sine alpha, which I have written here. Then if you drop a perpendicular from here to here will be your RF sine 60 plus gamma. That is also in the same direction as RC sine alpha. So both are added, and that is being opposed by RB, and the component of RE along positive x-axis, that is if you drop a perpendicular here, then this will be your RE cos beta. So RB plus RE cos beta along positive x-axis, this is along negative x-axis. So RE cos beta goes to the right hand side, is subtracted. All the values are known. Put it, this comes out to be 631.947 Newton. Slightly tricky while applying the equilibrium of forces at this point. You have to be clear about this angle, how this angle theta is 60 plus gamma. Let me explain. This angle plus this angle theta plus this alpha plus this much, that is 90 minus gamma is 180, which I explained here. So this theta came out to be 60 minus gamma. You might be getting confused here how this angle is beta, which I explained you here, because this angle beta is corresponding angle of this angle beta, because this line is horizontal, this line is horizontal, and the direction of RE is the transversal. So this angle is beta. Thank you.